All right, so again, we are trying to solve a problem which appeared in JEE Main 2023. In this question, we have been asked to find out how many solutions are possible for this thing, this expression which is given. So what is given is that S is defined as set of all x's, which are real numbers, such that x is a solution of this equation. And we have to find out how many such values of x are possible. All right. So whenever you see such an expression, anything which is a surd, right? And you see like root a plus root b and root a minus root b, think that are they reciprocal to each other? So that's your first what you call approach generally. So if you look at here and root 3 plus root 2, for example. So root 3 plus root 2, if I look at this, or I look at root 3 minus root 2, any of these, and then let's say I multiply this with its conjugate, which is root 3 plus root 2 in the numerator and the denominator. So root 3 plus root 2. Then in the numerator, this will become a minus b into a plus a, which is a square minus b square, which is root 3 square minus root 2 square. And that would be root 3 plus root 2 in the denominator. This will be 3 minus 2, which is 1 upon root 3 plus root 2. So what we are getting here is that root 3 minus root 2 is a reciprocal of this number. So I could write this expression as root 3 plus root 2 raised to the power x square minus 4 plus 1 upon root 3 minus root 2. Root 3 minus root 2 whole raised to the power x square minus 4, right? So in the next step, we could further write it as this is x square minus 4. In the next step, I could write it as this is root 3 plus root 2 x square minus 4 plus 1 upon square root of 3 minus square root of 2 raised to the power square x square minus 4. So this is the whole expression of this side, which is actually equal to 10. That is what is given to us. This is actually equal to 10. Now, what if I assume this entire thing to be a y? So this entire thing, I'm assuming it to be y. So this thing will become y plus 1 by y equals to 10. Why did I do it? Is because it was looking like a quadratic to me. That's the reason I did this. When I do this, then I get y square plus 1 upon y equals to 10. And in the next step, what will I get? I will get y square and then plus 1 equals to 10y. And then I could write it as y square minus 10y plus 1. So factorization of this is not possible. So what I will do is instead I will just find out the value here. So which will be, I could use the formula which will be this formula, right? Minus b plus minus square root of b square minus 4ac upon 2a. So what is my minus b over here is 10 plus minus b square, which is minus 10 square, which is 100. And then minus 4ac, which is 4 into a, which is 1, and c is 1. So 4 into 1 into 1 divided by 2 into 1. From here, what I get is 10 plus minus, I get 100 minus 4 upon 2. So this is 10 plus minus square root of 96 by 2. Or I could write it as 10 plus minus, this will be 16 into 6, right? So I could write it as 4 root 6 upon 2. Then I can take 2 common and divide it. Then this will become 5 plus minus 2 root 6. So what do we get? I get this y is actually equal to 5 plus minus 2 root 6. Now what was y? Y was nothing but this expression root 3 plus root 2 raised to the power this, right? Root 3 plus root 2 raised to the power x square minus 4. And this has turned out to be either 5 plus root 6 or 5 plus 2 root 6 or 5 minus 2 root 6. Now look at this expression closely, and then this is what we have to observe here, that if I look at this root 3 plus root 2 and then say let's square it, then what do I get? This is a plus b whole square. So this is root 3 whole squared plus root 2 whole squared, and then plus 2 into root 3 into root 2. When I do this, what I get? I get this as 3, this as 2, and this will be 2 root 6, which is nothing but 5 plus root 6, 2 root 6. So what we get here is that this expression on the right hand side, if it is plus, then this one should be root 3 plus root 2 whole squared. And in the other case, if I just do root 3 minus root 2 whole squared as in again, so I'll get same thing. I will get 5 minus 2 root 6 if I do this same manner, a plus b minus 2ab. Now, what is this root 3 minus root 2 whole square? Root 3 minus root 2, I just figured out this is nothing but root 3 plus root 2, right? Or this is whole squared, is 5 minus 2 root 6. So I could say that this is nothing but root 3 plus root 2 raised to the power minus 2. It will be square here and then I'll send it to the numerator. So what does this mean here is that when I take the value as 5 plus 2 root 6, then my x square minus 4 here will become equal to 2. Then basically what can I write it as? This. Why? Because this could be written as 5 plus 2 root 6, right? So this, what we are saying here is that root 3 plus root 2 to the power x square minus 4 is actually equal to root 3 plus root 2 whole squared. And this implies that x square minus 4 is actually equal to 2. So this implies that x square is actually equal to 6, or this implies that x is either plus or minus root 6. Similarly, here I could say that root 3 plus root 2 raised to the power x square minus 4 is actually equal to root 3 plus root 2 raised to the power minus 2. And I could say that x square minus 4 is actually equal to minus 2. And then I get x square is actually equal to plus 2, or x is actually equal to plus minus root 2. So here I'm getting two values of x, root 6 and minus root 6. Here as well I'm getting two values of x, plus root 2 and minus root 2. And these are all real numbers. That is what we had to have. I mean, if I had got something negative here, then I could have rejected it. As in, like, overall, if x square could have come negative, I would have rejected it because x was a real number. But if x being a real number, then how many solution of this is possible? We have got 4 such solutions. So in this case, your n of s would be actually equal to 4, and that is what will be your answer. So that's it. Thank you for watching, and if you have any questions, do ask me in the comment section below, and I'll be really happy to answer your queries. Thanks once again.